Hello everyone and welcome. This is our lab tutorial number 2 regarding the online series of tutorials. Alright, so in this lab we will be I'll be going through I'll be walking you through the new topic that it's actually the functions. So we will be we'll be together learn how to work with function, define a function, and first of all we'll be knowing what are the different types of function that we can use them and how they are actually helping us in order to facilitate the code and make it like more organized and well managed. All right, so recalling from your theory class, is that what is the definition of a function actually? So you can think of a function as a group of related code that has been gathered gathered together within within a specific definition, and this kind of code actually delivers and reflects a specific purpose or implements a specific task. Like for example here, so you imagine that like for example you have the main function. Here it is our actually that it's our default function and it's the first function that we are learning here. By default it's existed there in any C++ program, and within this function everything should be existed. Like all the code that we are writing, it should be existed. But we have learned before until here we didn't know, we didn't learn that there are actually other functions and there are other types of functions that we can create beside the main and link them together. All right, so here imagine, the purpose of the function, and let me just give you this hint before I'm going through I'm going through the details here, is that I will not be going in the theory details too much. It's just that I'm calling them, I'm recalling them, purposely and in a very summarized way. So if you tend to understand, or like if you're wondering how you could understand, or you could how do you want to understand like more related to the details of the theory and the concepts of functions, you can just refer back to the recording of the theory where you can have a plenty and generous explanations. All right, so from the implementation point of view here, so this code actually, unlike the functions here, happen to be scattered all over the program, and they have to be linked together. Okay, so we need to understand here that we should in any program we have to have one main function, only and only one main function, and as many as possible of different functions. This is number one. And point number two is that functions comes here in like a different types, to say, in terms of returning value. There are actually kind of two types: functions that return value and functions that doesn't return value. All right, so in this example here, the functions that return value, we indicate them or we refer to them. The functions that doesn't return a value. So it is just a function that perform a task without recalling any, without returning anything. Returning meaning that whenever we call the function and later on, you already understood and learned. What does it mean by calling? Whenever we call the function, it doesn't produce any value. So it is just executes whatever code in it. While the other one, it is the return function. All right, so as we know here, we have a main function, and it doesn't matter whether we use a returnable or non-returnable function. What can specify which type to choose is actually the purpose of the the question, or how the problem is actually being presented. If it is requiring that we need to to have a solution of, let's say I want to solve, I want to write a function or a piece of code that solves me x equal to y plus 6, for example, simple as this. So in order to to reflect what is the value of x at the end, for example, so you can use a kind of in this case, so this can be modeled or coded to say in an returnable function. If we, if the purpose was to read the value of x, or to use the value of x in another function. So why we return the function here? Why do we need to return a value of the function? It is because we want to use it in the main function or in any other function. Actually, it depends on where, the place that we can call the function. And we have already learned, known in the theory part, that we can actually return a function not necessarily to be in the main, but we can call it in any other function in the program. All right, so this is actually for you to go through. This is just refreshing of the, I mean, like the particular or the relevant theory that we have actually talking, we were discussing about before during the theory part. So again, this is actually the main function. Let me just, I mean, like return with you into the our compiler here. And by the way, this is actually the this is a kind of a very simple and lightweight compiler that it's called code blocks, as you can see here. I like this compiler. It's because it doesn't actually take a lot of space from the hard disk. Okay, unlike maybe because I mean, like before that we were working with a Visual Studio. Yeah, Visual Studio is a very it's a very very good and very detailed kind of compiler, and it even does much more than actually a compiler. But because you see the purpose of this course is only compiling a C++ code, that's why I think in my opinion Visual Studio is too big for us actually to, I mean, like to work with it. But especially like I'm talking about like your personal laptops or your personal computers at home. So if you're like looking for, I mean, like if you're afraid of having too much space to be in, I mean, like to be consumed from your hard disk, same as like what I'm having here. I'm running out of an SSD storage, so I had to replace that by a kind of another compiler. And code block here is a very good and very it's a very meaningful I mean, like kind of tool to work with. Anyway, so this is regarding the tool that I'm using here. It's very easy to set up and configure there. All right, so starting the I mean, like the program, include IO stream, and then using namespace std and int main. As we have said before, each program have to have a main function. We cannot actually perform any I mean, like we cannot actually perform or execute to say any program without having the main function on it. So we know that the main function has that statement that it's called return 0, and now this is the time to explain what does it mean by return. And you see, just now I was explaining, and if you remember in theory, we have called that there are two types of functions in terms of returning values. One actually that return a value, and the other one that doesn't return a value. And that one that doesn't return a value, we call it, I mean, like we indicate it or define it using using the keyword void here. For example, greet. Okay, so this kind of function, actually it's a function that doesn't return a value. It only executes a particular code. Whatever code inside that function can be executed here, and then that's it. So it doesn't, I mean, like whenever we call it, so it depends on the code that can be contained here, whether it has a display or like cout statements, then the code will be like displayed on the screen. If it only has kind of a calculation or like a declaration of or whatever kind of logic it has, then it just only performs this without returning any value. Okay, so the return function here actually returns 0. It's just a specific kind of return. It only happens in the main, or it only applies in the main. Why? It's because actually we want to indicate that, okay, so we are returning, I mean, like the exceptional error here, and this is actually another advanced topic beyond the scope of this course. It is to indicate that the exceptional, I mean, like the exceptional error here, or the error handling is already, I mean, like called off. So we do not need to bother about it now, but later on I will use this with you, the return keyword, in order to return a values in another functions other than the main function. So all what we need to know now is that the main function has to be the function that exists in any program, and followed by other functions. Those other functions can be built and created up to our purpose and, I mean, like the requirements of the question, to say, or of the scenario that we are trying to model. All right, so in the main function, as you can see, as you get to use to that, so you can either have a cout to say, let's say here I'm typing I am in the main function. And then I want just to execute that in line and then execute that. Okay, so because this is actually an undefined code, so of course it will not be like valid here. Okay, so and here I have another type of function that it's called void here, and let me just type another function that it's actually another int, and here in the int function let me just call it as int sum, okay, or like int value, get value. Okay, I just want to make this kind of function more like meaningful. All right, so what I have done just now is that I have created two functions beside the main function. The main function has only, like kind of a display message, and these other two functions, they are just empty functions. Okay, so from the creation here, we can note that each function should contain the following. It should contain something like this keyword, like we call it the type, the return type of the function. So void here, void is called the return type of the function. All right, so void, int, double, char, string. Okay, so all of these actually they call them, like we call them the return type. Void here, it indicates that this function doesn't return any value, while the int here, we have to end it up, like not ending it up, but it has to return a value. It's not necessary to be in the end, like at the end, but most practices are actually like placing the keyword return in the end, and then we have to return a value. Here it has to be like whatever value that we need to return. So most likely when we return, we are returning actually a variable name in most cases. We do not return actually like a specific number or like a specific value to, like a specific literal value here, for example. Okay, so what we return here is usually returning a variable, and this variable of course has to be defined. It has to be defined in a place before it's being returned, because returning a variable, it meaning that we are actually using the variable. And coming back to like to our famous rule or the common rule in variables, the variable has to be defined before it's used or before it's being manipulated. Okay, so this is it. So this is actually the minimal way how can we how can we make this kind of code executable. All right, so until now we have just created two functions beside the main function. So if we executed that code, it will be just only I am in the main function. Then what about the others? Of course, because they do not include any kind of say any kind of cout statements, meaning to display something. We cannot, of course, we cannot say we cannot see anything from the from the functions. Although, if if we, let's say that if we have actually put that created a cout function here, let me just copy that, shortcutting the time. And I just want to change a little bit in the text. I'm in the agree function. Okay, so this is it. And in the int main, well, so let me just make the variable more meaningful, of course, because if int x and only that's it, so it means that x has nothing inside it. Like x is just a variable that doesn't store any value in it. So if we want to store a value, we either can sign it like this, or of course, as you know, the other way is to be entered or assigned from the user using the cin object. All right, so let us just re-execute this again here, and we are still seeing only one statement again. So what is actually the what is the step that we need to do here in order to enable this function to be executed? You can see there is nothing wrong with it, and although it's only that the main function contents are being executed, regardless the other function. It seems that the compiler doesn't look at these functions at all. Okay, so in order to make this happen, and in order to make the function be aware of that there are actually some other parts of code within the program, it is because that we didn't do what we call the functions calling. So again here, a function calling, repeating from the theory part, is that actually linking these functions other than the main function, all right, linking these functions, whatever functions other than the main function, into the place where we want to call, of course, into the main function. Of course, at least, I mean, like if we have like more than one function, at least one of them has to be called inside the main, if we are assuming that the other function may be called inside that function. Okay, but here in our example, we are trying to make it very simple and assume that we just want to execute both functions from the main function. Okay, so in that we have to do something called like function calling. So function calling happens again, as you know, in the theory, it is just by typing the function name and with the list of parameters. So by the way here, maybe I didn't continue the explanation of the function definition here. So the definition of the function contains the, um, the return type, the function name, and also the list of parameter that actually happen to be located within the two brackets here. Okay, so this function actually doesn't has any parameter. That's why the brackets are only empty, so open and close bracket. But they have to be there. Even if we don't have any list of parameters, this should be a part of the function. All right, and then finally we have the function body that lies between the open and close curly brackets. Right, so this is actually the structure of the function. We call this as the function heading. Until here before the curly brackets, we call this as the function heading or function declaration. Okay, so over here it's the function heading. So most likely we used to use that bracket, just write the function for the purpose of manageability. All right, coming back to the function call. Function call happens to be like by calling the name of the function without its return type. Remember this, we do not need to include the return type here. So calling this function again and calling, like the other function, get value, it's already being placed here. All right, so in this case, we are actually calling both functions. But actually, there will be like one expected error here. If you remember during the theory part, I do not want to execute this because I want to save like more time in this. There will be like one error here. The error here is that when the compiler is passing through these, like the main, and let's just remember this again, the first place that the compiler is hitting after reading the header or the preprocessor part of the program is that the main function. So this is the place where the compiler is looking at. Even though if we have like the main function happen to be in the very end place of the program, so the compiler just goes and the compiler usually goes and it looks for the like the main function. Okay, so when it comes into the main function, there is one statement here to be executed. So it executes this statement displaying that text, and then it goes to greet a kind of this function. So this is seen like a function call. But the problem here is that the compiler doesn't know what is a greet actually. Okay, so having this function call here doesn't mean that we have defined the function. Okay, so because it doesn't include, like greets here come in a place without being priorly being defined in a, in a place before the main function. So that's why it's just something like similar to the terminology of the like the terminology of the, to say the variable here. So if you remember that time, if we cannot say actually x equal to 3 or like c out x, okay, or c out a val here or num. I'm writing it. Okay, c out num. We cannot say like this actually and just keep quiet about that. So when the compiler comes here again, it will see that, okay, so what is num here? It seems that num looks like a variable, but does this variable has any definition? It doesn't. Until the moment here, it doesn't. Even though if we came to the place here like in the like within the function and say that int num, of course this is wrong because actually we are defining the variable before, like after its utilization. Same goes for the function. So then how to tackle this problem now? Let me just keep this variable. I may need to use it, or like let me just delete it for now to manage the code. Much better. Okay, so in order to use that function, I mean, like in order to define the function, all what we need to do here is that to bring the function body, I mean, like the function itself, the details of the function, in a place before the main. So this is all what we need to do here. So it means that whatever function is being called in the main, it has to be until the moment. It has to be called, or it has to be structured or defined and created before the main. Okay? Not only the main, let's make the rule kind of more generalized way. Whenever we are trying to call a function, in any function, could be a main or any other function, its body and its definition, it has to be lies, or it has to be located before the call. All right, so even same goes for this, because we are actually like doing the same thing. So now actually the order of like which one comes in the first to be placed, it doesn't matter, and it doesn't follow this, as long as both of the functions are being defined here and are being created here. Doesn't matter the problem. I mean, like the important thing here is the definition of the function. As long as both functions are being defined, then there's no matter. I mean, like there is no problem to call them after like their definitions. So now if we just execute that, of course we can see now the content of the first function, which is the void function, that I am in the greet function. You can see that. And of course this one doesn't, I mean, like it doesn't return. So returning doesn't mean that we are we are printing out. Okay, return here doesn't include that we are printing out. It's just to indicate that this, I mean, like whenever we call the function here, we are returning, it has a value, something like the variable itself. I mean, like it's something like a variable. Let's say that whenever like we define a variable x equal to a variable, let's say num again equal to 7. Okay, so when we say int y equal to num, we are returning, I mean, like the value of 7 that it's being stored in num. Then we are using it and assigning it to another variable here. Okay, so this is it. So it is something like actually we are returning a value that has been used. I mean, like we are just retrieving a value that has been used in that function. So now the value of this function, okay, it will be the value of the return variable. So whatever variable here that has been placed in the return after the return keyword, it will be the value of the function. So now the value of the function, even though if we have like imagine that I have created another variable and call it like let's say for example 12 here, and I'm returning x. Okay, so what's the value of this function? It will be 9. Whenever I'm calling this function, it will not produce me 11 or 12, sorry, 12, or even if we are using char, let me just make it like so kind of a little bit varied from, I mean, like in terms of different variable types, g for example, and let me use another way of writing string equal to Mike. Okay, and double also k equal to a 9.34. Okay, just and random kind of values. It's just arbitrary values because we are trying to to demonstrate that now whatever, I mean, like the value of this function, it will be only one value. So which is the value of the variable that we are returning here? How to display this value now? Then okay, we are returning a value. What to do with it? Then meaning that okay, if we're just creating a value within, I mean, like any kind of a function here that has the variable, so how, I mean, like how can we handle that? All right, so we can handle it in just a way that we can, okay, for greet, because it only has like a display message, so whenever we call it, so it just only displays whatever inside it. Okay, even though for like if we have even a display here, let's say that I want to see out x, okay, and line. So in this case, now if I call that function, of course, because it has a display in it inside the function structure, inside the function body, it will be actually displaying the value of x. Let me see what's wrong here. Oh, let me type this as code. Oh my god, so just a fatal error here. Name, no variable names. Well, it's just a coincident error. Well, fine. See, this is number 9 here. Why? It's because it's being executed from the like the function body. So now we can see that we have the first I'm in the main function, then comes into the like the second the first function that has been called greet. That's why it has been like this statement has been displayed first before number 9. Number 9 happens to be returned from the get value, not return, actually it's been executed like within the code of the get value. Okay, so again, so what does this has to do with the return? If like if the value here comes from the display out, the question here, what does this has to do with the return? Let me tell you this one thing. Actually, when we talk about like different types of functions here, that we have a returnable, like kind of a function that doesn't return a value and a function that returns a value. Actually, in fact, the function that doesn't return a value, that it's the void function, it is actually a kind of a specific case or a special kind of function to say. The most common one, like the most general one that can do even more than more than one task, it is the returnable value function, or the function that returns a value, which is this one. When we talk about like int main here. Okay, so meaning that this is actually more, like it is like it has the like the features that can do it has actually the ability to do or to perform more features and more tasks than the void. All right, because here, for example, in the void function, if you're performing any task, let's say for example cout int x or like int r equal to 8, and you want to cout 8. So all you can do here is that you can only display r. That's it. But what if here, and this is the importance of the return now. That's why I'm explaining this. The importance of the return here, it's that, like what if I want to use r, and maybe now in this tutorial we are not going to go into that detail that we are passing values from one function or sending values from one function to another. That could be the topic in the next tutorial, hopefully in the next lab tutorial. And in this case, you will find the importance of the the returning value, a function that can return a value here. What if we want to like use that value? We do not want to print it out, we want to use it in another function. So this kind of function doesn't help us to do that, because it doesn't include the command that that enables to send values from it to like whenever it's being called. Okay, so in this case we cannot actually use void, but rather we can use any kind of returnable function. Could be like int, double, and whatever data type. So this is one point. The other point, before I just forget that, okay, so now we just understood that we agreed that the void here, it's just kind of let's say a special case, or like a kind of a a function that has a limited kind of features. In my opinion, I'm saying this. Okay, so all right, so the other point here is that the return value here, we are returning this value. So okay, so how can we decide whether this should be int, double, or like char? Okay, here if you just type any value, let's say for example I'm typing code here, with this actually program, like with this kind of state in this coding, it will bring an error. Why? It's because the char here, it is like the data type of the return here, it is different from the data type of the return here. So meaning, again, I'm just clarifying this, because we have defined this as the return type from the beginning. We agreed that even whenever we call this, what are the contents of the function? So the first thing here, it's the return type. So the return type here, it has to be exactly same as the data type of that variable. Remember this. This is very important point here, especially when you have like more than one variable and you are returning a specific variable, and then you decided to return another variable. Okay, so we should agree that here we cannot type the code like this. If we want to change like the return value to be here, like from another variable, like for example code, we need to look at what is the data type of the code, which is the char, and then we have to change this accordingly. Hope this be actually very clear. Let's say again, if we're going to use k, then this has to be changed into double to match with the returning value. Okay, so the return type has to match with the data type of the return value. All right, so let's just take this as let's just keep that code with this status now, and now we want to return. Okay, so we are returning, meaning that let's say we do not actually have that kind of cout. Okay, we want to read the value itself. We want to be able to assign the value, to take the value out, okay, to send the value out. So return, meaning that I can use the value. I can define a value here, and then I can use it in the place where I am calling the function. All right, so how can we do that? It's by handling. So now the value of the function, it will be the value of the return itself. So whenever we are like calling a function here, it will sure return the value of k. So because it does that way, we can actually assign it into int. For example, not to int. Let me just make it so simple and say right away cout get value. I can do that actually. Okay, of course I need to eliminate that semicolon because it's not the end of the coding statement. It could be actually like this, but I just want to end it with the end line, and then I can put that, meaning that I can join the calling within a print out statement, and this is very possible. This is very possible and doesn't have any errors. Okay, or I can also join, and the join has to be here. I can assign the value of that function into another variable, but of course the variable has to be from the same data type as the return type. So double, for example, u equal to get value, which is this one. Okay, so this is it. All right, so I can do that. It's possible. If I want to read the value also, I can do that. Let me just comment this out, okay, and execute the code now, and you will see the value of get value. All right, see, this is it. So 9.34, I'm able to read the value of the get function. Why? It's because it has been returned. Let me just change this. Okay, I'll need to be change it into let's say name. Then what should I change also here? Anyone? You should actually be thinking of this very fast. It is this one, that it has to be string. A string, the return type, and then here, of course, I don't need to change anything in here. All right, so let me just execute this again, and you can see that the name has already appeared. So it depends on the return of the value that happens here. Okay, this is very interesting kind of very interesting type of function, and personally I like to use this function even more than the kind of void function. So because void functions here are only used to perform a specific task and that's it. And to be more frank with you, there is actually one topic that we will learn later on in the end of this chapter, that it's called the local and global variables. This actually gives that kind of non-returnable function more advantage in this case, because since that void function doesn't return a value, so in most of the the huge projects, to say, or most of the practical projects or programs in the real life, is that these functions are being used to calculate something and then store them in a store the output in a kind of a global variable, something that we will learn later on. Then this function became kind of like more important and has more sense. Other than that, actually the kind of returnable functions, like main int, string, double, char, these actually can do and handle more work and more features that they can actually allow us to work with in comparison with the first type. All right, so I think this is enough of the introduction to the both of the function. What we have done just now is that I have introduced you I have introduced you both types of the functions and how we can handle them. How can we copy a code? I mean, like, how can we write a code in the functions? All right, so there is another point that I would like to share with you. It actually just come to my mind. Um, Actually, if you notice me, I'm not following like the word by word, whatever in the handout here. Of course, I'll be submitting this to you. I'll be giving this to you that you can go through. But whatever I'm explaining, it's already here. All right. But because you see, in programming, good thing is that ideas are too much, and whenever you're explaining one topic, I mean, like, because the programming, like, it's like a math, that the I mean like the ideas and the tricks and keys that you want to explain, they are too much and you cannot actually make them standardized. All right, so the more, I mean, like, it comes from like the mistakes that we learn and that mistakes that we fall into, or like from the experience that we can pass through, I mean, like, with the previous learners. All right, so before I just forget that, let me just share with you this point. All right, is that let's say, let me just delete all of this. I don't want to mix it up, and just make it, you know, like, return this to num. All right, and then have this to be as int num equal to, let's I mean, again, I'm going to use it. All right, and this time what I will do is that it's possible also to let the user read that variable. And let me just take the chance here and write the code here. So enter value for num, as you know, and this is very common code that you are being really familiar with from the previous tutorials. And cn num. All right, okay, what if, and then I return num here. Okay, so okay, what if here I want to say that int can, okay, the first question here is that, can I say, since I have already defined num, and let me just assume that this function has been placed here after the main, I mean, like, sorry, after the get value. Okay, can I say this num equal to 6, for example, assuming that num is already been defined in here? And actually, this is a kind of a common mistakes. Unfortunately, this is a kind of a common mistakes that some students have, I mean, like, have passed through, to say that. Okay, so assuming that num has already been defined here, can I use it here again? It's already defined. So I mean, like, to any of you who is not actually, I mean, like looking thoroughly into the program, you will assume that, yeah, okay, fine. So since we are defining the variable at the beginning, there's no problem to use it. So let's just execute and see that. And oh no, there is actually an error here. The error here, it indicates that num was not declared in this scope. Yeah, it is because, and this is another point that you need to take in your mind, is that, so whatever variables or whatever code has been confined within the open and close brackets of any particular function, I mean, like, the scope of its variables and the scope of its objects, or whatever kind of I mean, like, structure in it, it will only be valid only within the two brackets, open and close, the open and close curly bracket. Meaning that if we want to use the same, I mean, like, variable name here, we need to assume that this does not exist, because at the end of the function, that variable will not exist. I mean, like, at the end of the function, this variable will not work. Again, here, we cannot actually, like, naming or using the same variable name here, it doesn't mean that we are duplicating the value here. It doesn't mean that we are duplicating the value. It means that actually, I mean, like, the compiler here is looks at that code as if that variable is kind of separated. So if we have defined, I mean, like, executed that, we should have no issue here. Okay, even if I have typed like any kind of number, so I'm having it. Let me just see out this to show you even the impact of the idea that I'm saying here. Return num here. Let me just read num, then get value. All right, so because we are reading num now. Okay, so what does this code do is that, first of all, it actually it creates a variable called num in a function, which is a returnable type of function, and then allow the user to enter a value and then returns that value that has been read. And this is a very common practice for, like for this kind of function. It's a very, very common practice for this kind of returnable function. In many of the questions, like the question usually used to ask, create a function that asks the user to enter a value and then return its type. Like return its value, whatever value has been read from the user. And then in the other function, we can use it in a particular way, like maybe to print it out like this, or to assign it into another variable that we can, as we have seen. But the important thing again here is to remember that, so whenever you are like returning a value, make sure that the assignment later on happen to be as the same type as the return, right? So like this, if you're doing that. All right, so let's just execute this and say 34. So 34, the user have entered 34. Oh, it's because I didn't indicate that. So here and line. See, enter num here 34. So it seems that actually number here has been isolated. So like the compiler here looks at the number here as variable that has no confliction with the name of the above function here. Like with the variable in the above function, although the names are typically the same. But of course, you see, at the end, like at the end of the day, I'm saying that this is actually not a good practice, even, especially for kind of a beginner learners who are trying to, like to build up their experience. Why? It's because, of course, for sure you'll be confusing on that. But like, like from the point of learning, I'm telling you this is very correct and it doesn't has any issue. And we cannot use number here, assuming that number has been defined in the above, meaning that I cannot use it in this way, but I have to define it again. Why? It's because here num happened to be in a different function than the function that the previous value was in. Okay, so meaning that the compiler here looks at these variables as two different variables. All right, so let's just keep this enough of the practice in here, and let me just move with you and to you can actually read these points. They are actually very important, and they can even refresh your theory and like your conceptual details in the function. So you can see like this. So the return here, again, I'm telling you, so it is not just about returning as a fixed value. You can also return, define num. Let's just take it like one by one here. I will just comment this out, or just much better to delete it. All right, so you can just allow the user to enter num, and then you can use int, for example, z x equal to num multiply by what, 3. All will be divided by could be 0.5 or 0.4. But here, of course, we need to take care of this to be double. And what else? And here I can actually return x, but I need to change. What should I change? This one. Sorry, I need to change the return type, like in the function definition, to be double. So in this case here, again, whenever I'm printing this value, okay, let me just not print this out. I just want to use the other way, is that I want to store this value. Instead of printing it here and see out, I just want to store it. So of course, whatever variable that can be stored is holding that value of the function. Of course, it has to be of the same data type as the return type, and of course as the variable that I'm returning here. All right, so of course this needs a semicolon. Okay, so here I'm just assigning that value and I want to display it from this. So of course that would be typically the same value here, because I'm copying the value into another variable that it's actually a member of the main function, and then I'm calling that value. So at the end, the result is typically the same as if we have copy pasted that one in here. It is typically the same. Why? It's because the same value will be printed here, unless we can actually do, like kind of work on it, or like kind of performing an operation on it, like for example dividing by 2. Here we are using that, like that kind of function. All right, so we are using it as a value, and then you can actually display that out by saying, for example, u, the value of u is u, and need some indent brackets here, and then another one saying that the value is c out, the value of get val, the value of get value is get value. It's already printed in here, and then end line. All right, so you can see now there will be like a different. What we have done is that we can use actually the value that we are returning, of course, by calling the function name. So here, this is a calling. Okay, so this is the function calling. It's typically the same as this. So this is a function call. It can be, of course, because this is void. So in the void, of course, we don't have actually that. I'm sorry for that. We don't have this anymore. Before that, we had it. So we can just simply omit it. Even if we keep it, of course, it will show an error, because now the compiler will read there is a greet here. So greet, it has to have a definition. So where is the greet? It's not existed. So that's why this will bring an error. So so here get value here, it's a function call, but it's already being used within the variable. We cannot actually, we don't need to call the get val here in prior, then so that we can use it, because with this will have, this will make no, it will have no benefit, or like it will have no issue. It's something like we are actually duplicating, it, because here we have no, to say, it seems that we are going to execute this function 2 times when we just make it like this. So whenever we have a kind of a returning value function, so it's like much better to use it in a place that we are going to use it at, rather than just keep calling it. Unless we have that void function that prints out something that, as I show you just now, then you can just place it in a one separate line. Okay, so executing that, it will show us that enter a value for num 65. The value of the num is 65. Enter value of num. Let me have, I think this code is not arranged too well. All right. Okay. So for 30. All right. So so it is just like that. So the value of u here is, so this is the value. All right. So let me just execute it once again to make it more clear. Enter value of num, which is, this is the one that here I'm in the main, and then it executes this. So the value of u, oh yeah, I know where is the error, or like the confusion here. It is because, you see, we are performing it, we are calling the function twice. See, we are calling the function twice. All right, so actually we cannot because you see, once you call the function, all the code will be repeated once again. All this code will be executed once again. That's why you can see here, if let's say I enter 3, then I need to prompt again to, I will be prompted again to enter another value, and then it will finish up. That's why you see we cannot actually display it out like this, unless you are actually you just meant to do that. But that's actually the most proper way. So for here, so the value will be 15, and then if you want to read the value of the function, of course you'll need to enter another value, because it contains the user input. Okay, all right, so coming back again here, so again we have taken the void function here. How can we execute functions? All right, here we already know that, and how to call the function. Of course, the execution here, if we created two separate functions without a calling, so without a function call, we cannot execute the function. So each function has to be executed in the main. All right, so let me just move with you. These are actually important points that you need to talk, that you need to know about. For example, our function is called that main function. We call it as the main function here. We call it as the mother function. All right, so we call the main function as the mother function. For the whole program must be existed, any program, and its type is a return function. So what is the type of the main function? It's a return function. All right, so like main function, other return functions, void function can contain any type of coding, okay? So it can be like formulas, loop, nested loop, any kind of logic. You can actually go through this. I'm not going to explain it one by one because it has been explained in the theory, and it will be like very easy for you, especially in this case and like in this stage, to link the theory with the practice in here. Okay, so all right, so let me move into the other one. We have already explained this in practice just now. What we have done here, we have explained all of this in practice, and you can actually look at these as more examples and try to implement them in your compiler here and see what are the different outputs that you can get here. See, for example, this one is actually like defining two numbers and then dividing them and then returning the value of the value of the division. All right, so this is the value that we should return, and that's why the type of the function is double. It's because the variable that we are returning, it has a double data type, and at the end here, this is how we execute it, as I have shown you. Let me just close this. As I have shown you just now in the compiler here. All right, so order of the function. Again, as we have mentioned before, so if you have like more than one function, okay, let me just simplify this. And now let's just talk about kind of the void functions, because they are much simpler to implement. However, they are, as I mentioned to you, they are kind of limited. They have a kind of a limited features in comparison with the returnable functions. So first, let me just call this as first. And then I'm having a code here. The code here is just a simple cout, okay, that has, this is the first function. Okay, so end line, or just simply, let's just make it /n to make it faster. All right, let me just copy this again because I'm creating another function and just changing. This is the second, of course. And this is maybe another point that come to my mind. Of course, we cannot duplicate the function names. The same situation as into the variable name. We can use the same content. We can use the same variables. If we have written here int x, I can write here int x with no error, with no issues. All right, but I cannot use the same function name. So this one has to be changed, even if it is something like this. Okay, but anyway, it has to be changed. So for the better of naming, I'm calling it second. Okay, so void second. All right. So remember, this is important. So we have to make differentiated function names, but the contents might be the same, even typically the same. All right. So of course, this has to be the second function. Why I'm doing this is that I'm just going to show you something that even I think you have already been noticing this, but maybe I didn't. I literally didn't talk about it. But like when it comes to calling the functions here, let's just call the functions. How we call them, as you know, it is just by typing the function name. So first, let's say I'm calling second here, and then I'm calling first. And I think this is a very trivial point. I think you may need to, it may already came to your to your mind. Is that so? The question here that explains what is this is that when you execute that kind of output, that kind of program, which output will be displayed in the beginning? Let's assume that I'm having here, this is the cout. This is the main function. All right, so which statement will be displayed out? Is it this statement here, since the compiler is lying here, or this statement here, since this one is named as the first, or this statement here being the second one? Okay, so here order is important, and how order is being decided, it's because it is decided in the main. So the compiler comes, as we have said, in the main function and executes line by line. So the first line here happened to be the name of the function called second. So the first thing the compiler is doing here, if there is no code in the main, before that line of code, is that it goes to the second function, this one, the function that has the name second, and then executes its code. So here the code is just only a cout. This is the text, so it will only display this text. This is the second function, and then gets out of the function, comes again back to the main function, and then executes the first. So again, this is another call in the first, so it goes back into the first. So meaning that it leaves the main. The main function will be left and going into the function that it's being called, executing its code, and then coming back again into the main. Okay, so here for the second time, the compiler leaves the main, going into the first, then executes this code. So this statement happened to be the second statement after this statement. And then at the end, it comes here. However, this is the statements that happen to be in the main function. Although, at the end, as a result, this is the last statement will be executed following the order that we can see here. So showing this, you can see this now. So this is the second function because the second has the code of the display as this is the second function, and then the first function, and then the main function. All right, so here this is what it means by that kind of diagram.